Good morning, good afternoon, and good evening, everybody. Welcome back into the Dragon's Den. My name is Digital Dragon. Everybody's doing well and good today. One second. That camera's looking a tad bit high. Monitor. There we go. A little bit better. Like I said, I hope everybody's doing well today. It's Thursday. It's one more day closer to Friday. Hey, Friday! We're wearing the black Digital Dragon shirt today. Just showing off the new merch. Hey Chewy, how's it going? Mr. Wizix, Killer Preds, hey. Hope everybody's doing well. So today we're going to be continuing on the RatRig and the commissioning process and kind of where we're at. Hey Ten Talon, hey Eagle the Dragon, welcome on in. We got to make sure that the gantry is not racked or twisted. And to do that, sadly, we have to take off the hybrid motor belt. Well, the way that they're on there, it means it's going to be a lot easier if I take the side panels off, which I've been trying not to do this whole build. Had I realized that we were going to need to take those belts off to do the commissioning process, I would have had the side panels off this whole time, which would have made rooting around in the printer a lot easier and getting better angles. I apologize for that, but that is where we are at. I did take the time because I'm not sure how long it's going to take to commission this and get some tests done. I have some 3DO carbon fiber, carbon or glass filled. Give me one second. I have some 3DO ASA glass-filled RatRig green. And yes, that is loaded up into my AMS. I did run it through the AMS. That just means I have to do some repairs. But yeah, we printed some parts for the RatPack. Getting some, I don't know. It's not a layer shift, but it's more of a Z-banding issue at features on models. But overall, everything printed great. That circle that you see there is going to be for the O-ring that seals this up to the fan. But everything printed great. And this is the RatRig green, so it should match very close to the green that comes with the printer and the printed parts that I had gotten from RatRig. So that is going to go there. That's going to go. Okay. So anyhow, we got the stuff for the RatPack. But before we go ahead and do the RatPack, I want to get this printer, and by this printer, I mean this printer, actually moving and fully commissioned in. Now, one thing, hey Pez, how's it going? One thing that I will mention, I have been using Orca Slicer on here. And Orca, they're building support for Orca and one other super slicer, I think, full super slicer support right now. But everything for the IDEX version is in Prusa Slicer. Meaning when you go into Orca Slicer, there is not a RatRig V-Core for IDEX option. There's only the standard and the hybrid motor option. The only thing that's got a pre-built config for slicing and stuff for this is going to be Prusa Slicer. So we will have to make that adjustment. But once again, we are to the point where we're going to start working on gantry twisting. It's in the nightly build for Orca Slicer. If so, that's new. It's not posted that I was aware of on their website. That is good information to know. What am I doing here? This one. So thank you for that, Kiloprints. So the next steps we have here is gantry twist. And this, gantry twist significantly reduces V-Core performance by introducing unwanted drag in the system. Basically, and it says gantry twist. Normally when I think of twist, I would think of a twist in this extrusion where it sounds more like they're talking about racking here with the way we're going to be checking this. In most cases, the issue is too subtle to detect by eye. Please take the following steps below to ensure your machine is properly prepared for printing so that we don't cause undue stress on the printer. Before beginning this chapter, it is crucial to ensure the gantry moves smoothly without the belts. Well, we had belts on it, so yeah, we're going to assume that the gantry, well, the carriage moves smoothly, yes. And that both joiners on the gantry makes contact with the stepper motor cages simultaneously. This is the piece that we're going to be doing. Okay, so we're going to have to send it a command for an M18, and then we need to remove the top Y belts. Yes, it's necessary to achieve optimal performance. That's where I'm saying at this point, I'm going to have to take the side panels off of this, which I've been trying not to do, and be able to get in here to these Y belt fasteners to take the Y belts off. Now these are whatchamacallits, hammerhead screws or nuts. So it's not that hard. It's just trying to line up all of these nuts at the same time to get these panels on. It's kind of a pain in the butt. And the one that is the biggest pain in the butt is this one right here in the middle. Everything else is fairly easy, but if that one in the middle gets cattywampus on you, it's hard to get it straightened out. Get in there, but we'll fight with that, or I'll fight with that off camera, so you don't see me. You don't see a grown man cry, basically. I'm going to put this behind the front. Well, plan will be to put these over here behind the front door panel. But this way I can get in and we can get in and take the belts off. And I'm probably going to go through here and read the instructions just a little bit more to make sure that, like, do I just need the belts out of the way when we're trying to do the D-rack procedure? Or am I going to have them off there to do some input shaping stuff? Like what do I need the belts off for? Because if it's just for the deracking process, I should be able to get away with just loosening the belts. If it's for more than that, though, then yeah, we're gonna need to take the belts completely off. Because once again, we want to get good and appropriate performance out of this. Hey, Shrimp Father, how's it going? Remove the Y belts. Slowly move the tool head to the center of the machine, then slide the gantry back. Squeeze the gantry joiners against the stepper motors. Deal with the belt tension to get it squared so that they're touching and not doing things. And then do a resonance analysis. Yep, so that tells me I need to take the Y belts completely off. Let me see. I'm going to try and open up the thing here and find the section on belts, or at least hybrid belts. toolhead, IDEX, alignment. I think it was in the, like we go through and we commission it out belts on, without the Y belts on. You'll have the Core XY, accessories, electronics, closure, hybrid, and IDEX Y belts. Okay. What I'm trying to do is just figure out how the Y belts go on there to make sure that I can take them off in such a way that it's easy to put them back on in the exact way. Oh yeah. Yeah, so we're gonna take the covers off. We will relieve the tension on the screws, which I believe these are M4s. Yep. Now what I like to do is kind of do these in a known manner so that hopefully when I put them back together, I can go back to that same known manner. And what I mean by that is I've got my Fabrico logo on here facing up. So I'm going to do 1, 2, 3 turns. Okay, so my belts are really loose and it's 3 turns. 3 turns. Same thing on the other side. So kind of figure out where the logo's at. And kind of do the same thing. 3 turns. There we go. We've got 3 screws on here that need to come out, and this is going to reduce or remove the cap. And then what we'll be able to do is pull one side of the belt out and pull it through, and then we can kind of do everything else. And these belts have been in here for a year, so we should be able to get them back into the same position. Okay, yeah. 2 more screws in here that hold these onto the lower carriage plates. That's basically trying to minimize the disassembly to the least amount possible. Okay. That comes off. We need to fish one side out. Easier said than done. Oh, there we go. And hopefully there's enough memory in this belt that it'll work for us down the road. There's one side. Do the same thing over here. We'll take the 3 top screws out, take the top plate off, get the 2 screws that connect it to the lower or to the carriage. And then we'll pop the belt plate off, move the belts, which might be a bit of a pain in the butt to route again, but it is what it is. So how's everybody doing tonight? One more day closer to Friday. Anybody got plans this weekend? As I mentioned on last stream, and I will reiterate today, I'm not going to stream on Saturday because I am going to assist Ecovate 3D, which is a 3D printing shop here in North Carolina in Raleigh. I'm going to help them move into their new digs. So I won't be able to stream on Saturday to go and support them in that. Okay, so once again, our belt paths kind of go like this. It'll make like this big P shape. It'll do it on the other side as well. So luckily we've got belts that are pretty much bent into shape that we'll be able to work with when we go to put these back in place so that we can hopefully get them close to tension and then fine tune it a little bit later on. So the Y belts are now out of the system. We're going to run M18 command here. And all that does is, I believe M18 is shutting the motors off. Hey, Los Inc, how's it going? Hey, Chewy, you're going to pull the stealth burner apart and figure out what the issue is. Might work some overtime. Okay. Hey, Reprinted, how's it going? Time no chat, no see. Okay, so now that we've got M18 installed or entered, it says to remove the top Y belt. We did that. Slowly move the tool heads to the center of the machine and then push it all the way to the back. So we're going to take our tool heads, center them, and slowly push them back. And what we're looking for is to make sure that when they contact, they're both contacting at the same rate. So let me see if I can't bring you guys around here. So what we're looking to do is we've got these, centered, and we push this to the back, push the joiners against the stepper motor cages and feel for any movement. So if either one of the idlers is contacted before, when I gently push on the carriage here, I will feel the slight shift. Okay, so I am fully connected right here, and I've got a gap on this side, fairly significant. So because it's significant, there's two things that I can do. I can tighten this one up, which is going to tighten this belt, or I can tighten one and loosen the other, because we really want them to be equal. So by loosening the left one, I'm going to loosen that a half turn. And I'm going to tighten this one a half turn. Bring them forward. Push them back. Still have movement over here on the right side. Okay, let's try that. Let's do a full turn this time. And what I'm doing is I'm pulling it back forward, just kind of to give it a chance to reset those belts. I'm back touching there. And this gap, maybe seems like it's getting wider, even though I'm tightening it up. Loosen the screw on the tensioner blocks or adjusting the belt tension. Oh, I'm doing it the complete opposite way that I should be. I should be loosening the one that's further away. So we did 1.5, so I'm going to actually start off doing it 2. And then this one I'm going to tighten back up 2. So it helps to read the manual. And push in on the left. And hey, the right got closer. Good. Looking at that, we're probably going to be 1 revolution. So this is the one touching. So we need to tighten this side, which will pull this quote unquote away. Do 1 full turn here. And I'm going to do 1 full turn to loosen this one. Feels like there might be a little bit of a gap there now. Fully touch, and we have a slight gap here. What we got over here? Have a slight gap here as well. I think we might be close. Let me throw some additional light on here. And I'll show you. We're looking at this gap right here. We're fully back as far as it's going to let me. And we've, we've got a slight, ever so slight gap right there. And on the other side, we've got an ever so slight gap there. And the entry is all the way back as far as it's going to go. So I'm going to say as long as these, don't say as long as these. You want making contact stepper motor, which it looks like is towards the bottom, not the top. Something, okay, it is. It is the bottom rear side that's making contact. Looks like there's a little movement there. No movement here. So a little movement on the left-hand side. So the left-hand side would need a slight loosening. We'll do a quarter turn. I'm still seeing movement over here. Or when I push on this one, the whole thing moves. So this one needs to be loosened up just ever so slightly more. Do a half turn there. We'll grab the screw that I just flung across the room. Root these around again to let the belts relax or recenter themselves. I'm still seeing a slight bit amount of movement over there. Do this one more time. Yeah, I think we're close. I think we're close. What do you think? Are you seeing that much movement right here? Or any movement without the whole printer moving? Ever so slight. One last one. This should be it. Classic overcompensate. So, who was the one that was asking me for the longest time if I would do a Ender NG? All right, there we go. I like that. Was that Timor or was that you, Pete? I can't remember. I think it was one of the two of you. So we did the manual adjustment, tighten the set screws on the tensioner body once you have finished. Yes, the set screws that I keep forgetting to loosen, hopefully that doesn't change anything. Actually, I think these were loosened from before. It was the upper ones that technically weren't. These ones were loosened up when we took the belts off initially. So we're going to snug these down, and by these I'm talking about these set screws right here, they're going into the side of our tensioners to keep them from backing out. Resonance analysis. Hey, Wilk Allen, how's it going? All right, so Pete hasn't responded, so I'm pretty sure it was Timor that kept asking about it. So Fabrico just announced that they are carrying, or they will be carrying kits for the Ender 3 next gen. I think it's version, was it 3.1 or something? Let me pull it up real fast. Hey, people have box turtle enclosures. Rax flex arm kits, box turtle, positron PCB bed, filament, of course. Bup, bup, bup. All right. Oh, well, maybe they don't have it up here. They must have just announced it on the on X and on Discord. So they're going to have kits for the Ender 3 next gen. He posted that on X, and I pinged him and said, "Hey, Fabrico Hector, maybe I should get one of those, or should I build one of these?" And he said, "Sure, no problem. I'll send you a prototype kit." So I have no idea when it's coming. I'm also supposed to be getting a prototype Baby Belt Pro from him. I say prototype. It's not a prototype, but it'll be one of the batch one kits he's going to send to me to build on stream. So we'll be able to do a Baby Belt Pro, the Ender NG. We will have the Elegoo Centauri Carbon that we ordered that'll come in this summer. And let's see, we will also be doing the Cyborg or the Trident 350 upgrade. We've got the Cyborg kit that will go to CNC motor front idlers and XY joints, 9mm belts, and a cartographer. And we're going to put a takeoff tool head with a tube, and it's either going to get the FXD with an LGX motor or the LGX Pro extruder on it. So resonance analysis. Real-time analysis tool enables real-time resonance analysis of your printer, allows you to set the printer to resonate at the specific frequency and direction, facilitating a detailed mechanical assessment. With this tool, you can more effectively diagnose potential mechanical issues within the machine. Okay. Following chapters will cover belt tension calibration and input shaper. During these stages, you can utilize the resonance analysis tool to troubleshoot and diagnose any mechanical issues. Okay. So it says we want to go to the real-time analysis button, select the accelerometer. Using the IDEX machine, you choose the tool head. So real-time analysis. Stream accelerometer. Tool head 0, which is set 2. So where we're at. Do the stream part. Start to activate the accelerometer reading. Select the resonance direction. Oscillate X for debugging in X. Y for debugging in Y. Oscillate X, Y for resonance in the lower belt. Okay, so I'm just going to kind of center the tool head and the tools because I don't know what it's going to do when we go to do this. So oscillating X is debugging X-axis input shaper spike. Y for debugging Y-axis input shaper spiker noise. Oscillate XY for diagnosing resonance in lower belt. Or X plus Y for belt tension graphs are meant to help you troubleshoot the machine assembly. Do not look at it as tuning tool. Very easy to over. Tools, oscillator. And there's frequency. Used. Is Luke Mia? Eh? Luke is not Mia. Luke is here though. Luke is off screen trying to read the directions to figure out what it is that it wants me to do. There we go, belt tension. Click the designated button inside the scripts window. I'm so confused. I have no idea. I have no idea what I'm trying to do. Now it's telling me to do stuff in the scripts. You hear nothing. I see nothing. Yeah. Only a little more. I do like he reads the manual. Well, and that's the thing is I'm trying to read the manual because I know it's so small and tiny on the screen. And I'm trying to understand load, unload, join, calibration, PID. Okay, measure core XY belt tension. Okay, so it looks like some things have changed as far as looks like some things have changed as far as what it does and where the things are at. Yeah, so I'm just trying to run the belt tension graph stuff right now, trying to follow the manual. And I don't know if it's really set up for IDEX here or not. It's only running one of the two belts. But I can tell you it is starting to shake everything on the top panel, so. For giggles, not for giggles, but take that off. Oof. Back over here. Try and reduce the amount of stuff that's shaking and wiggling on this thing. So Timur, how's it going? Timur, were you the one asking me about a Ender NG? Whether or not I would build one? You should need to check your hearing aid battery. I'm talking. I'm talking. I'm talking. Hey Timur, can you hear me? Can you hear me now? Can you hear me now? Can you hear me now? So we're running the process to check the belts, and what we're doing is just trying to make sure that the belt, if the belt frequencies are at least close and spiking in the same place, then that means our belt tension is about the same between the two. But Timur, if it was you asking about the Ender NG, long time ago, yes. Okay. So Fabrico just announced that they're coming out with kits on their Discord and X. And I pinged him saying, should I build one of these? And he responded that yes, he will get me one of the prototype kits. Now, as far as when that gets here, I do not know. Yeah, I don't think my macros are set up to be aware of IDEX. Can he get you one? I don't know, Killa. Reach out to Fabrico Hector. He likes to get people stuff. I'm trying to get KB3D to send me a Frax kit because he keeps talking about sending me panels for the black stack. Since I built a prototype black stack based on a now several months old CAD drawing. Timor, I hope you can hear me. If not, yeah, check your hearing aid. Make sure it's turned on or needs batteries. But yeah, it looks like I'm going to have one of those at some point in the future. I don't know when. Like I said, I'm checking with KB3D to see if he'll send me a Frax kit that I can build. We'll have the Elegoo Centauri coming in unless I decide to change my mind and cancel the pre-order. I was looking at the Airy One. What is that? The Airy One Thinker 400, and I decided not to pull the trigger on getting in on that, just because it's another one of those. Oh, we'll do it on Kickstarter. Well, why? Why not just take pre-orders? Why do it on Kickstarter, right? Because pre-orders, if they don't deliver, they have to give you back money. If you do Kickstarter and they don't deliver, they get to keep the money, which is a bit annoying. Okay, so that looks like it's possibly done running its stuff. It's going to generate the tension graphs. And there they are. So, click image to download. All right, so let me open both of these up. Bring them over here side by side. Go full screen. Okay, and taking a look at these, we're looking to make sure that they're spiking in the same spot. So we got a spike here. This is kind of, yeah, this one's a little bit off. Which is this? This is the extension. Looks like one might be just a tad bit off. Still looking good. Once again, this is not input shaping. This is belt tension. All this is. And I really need to look at, once again, toolhead vibrations generally cause vibrations in the lines around 100 to 150 megahertz. One side, here's the other. Yeah, here's some noise, 100, 125. The other one, not so bad. It was more higher up, but actually, this is the X, this is the Y. So it was Y as it's banging the front constantly. So that's probably where that came from. There's an issue with the belt path if your graph lacks 1 or 2 peaks. Most likely indicates your belts are rubbing against something somewhere on their path. It can be an idler, motor, pulley frame, etc. Only one belt path is having an issue. Let's go back to our graphs and see what we're seeing. Nope, one major spike, one major spike. Once again, I'm just trying to see and make sure that they're spiking in about the same area here. And in this case, there's a little ripple on the front and a ripple on the back. Vibrations are zigzaggy where swinging shows a smoothened curve. I think that's what we're seeing. Kind of jaggy there. A little bit of swing. Once again, I think we're good enough to continue here. I mean, Bluetooth devices in range, well, that can happen. Yeah, the Elegoost and Cherry Carbon here behind me. Oh, so you're one of the ones that got a review unit. See, I really actually what I need to do is I need to start reaching out to some companies like that and start making those connections because I should be able to. Um, yeah, the Anycubic Cobras. Well, when it was plugged in was working good. Um, it's downstairs right now because of the work we're doing here with the RatRig. I need to move too much stuff around to make room for the RatRig. So it was easier to move that downstairs for now. Once we get done with the RatRig and the black box are back in place, then we'll bring the Anycubic back up here. What do you think about the titanium gantry tube that are sold for the RatRig and some others? I don't know. A bit nuts. I did the carbon fiber tube upgrade from Chaotic Labs to the Voron 2.4. I have since pulled that back off. Didn't like it as much. And I had to pull it back off in order to do the Filomatrix because there was no place to connect the plunger for it, right? You order an everyone thinker hoping that it's a stand-up company and you don't get screwed. Well, and that's the thing. Like they've sent a bunch of boxes out. I saw Manic Really and a bunch of others that came out with their reviews. Or excuse me, they're unboxing. They can't do reviews yet because, well, it hasn't been out really long. And in their hands yet. They're basically doing first impressions. In order to do reviews, you got to have it for a while and put a good amount of time on them, right? It seems okay. Yeah, don't know. So here's the thing that's getting me worried is switching track here. It's showing me this thing with scripts and I'm not seeing scripts anywhere. What I'm seeing is, you know, calibration with input shaper, there's debug, there's IDEX stuff down here, but it's IDEXy stuff, which sounds good, but the calibration stuff seems a little bit different. And okay, you can select toolhead, you can select axis. Just I'm somewhat hesitant. Different. And I wonder, because I just clicked and did the whole thing, does this also, yeah, this gives me toolhead stuff. So that might have been my issue. Let me do a M18. I'm gonna switch these back to the center and sort of middled. And we did an M18. Now I'm going to come down here. I'm going to try this again. I'm going to do belt tension T0, axes X, and do a send. That does. Including G-code macro. Oh, I guess I just have to 0 or 1, not. Okay. So it looks like it's going to home now. Hey, Zombie, how's it going? Used the new mug today, a dark mode 15 ounce. Very nice. Very nice. I'm not using a mug today right now just because I had coffee from way earlier. So Zombie, I think you said that you did not, like, were you expecting Elegoo to send you a Centauri, or were you just saying basically, haha, they didn't send me one as a reviewer, so I don't have one to look at yet? Because I've ordered one, and their shipping, according to the shipping one I ordered, said it won't be here until like June, July, something like that. So right now, I've got the Anycubic that we have here that's downstairs. You bought it at launch. Okay, gotcha. It's stuck / lost. Okay, you must have got like first right when they started shipping. Because by the time I ordered, I think it was telling me June, July, like probably second batch or whatever. I'm not getting an Area 1 thinker. Just the more I think about it and looking at, so here's the thing. When I saw Mandic's video on it, right? Nice that it comes built. It's got an enclosure. It's on wheels, easy to move around, yada, yada, yada. But at the cost, and I'm looking at it and going, it's a 400 size, and there's no IDEX options and stuff like that. And looking at the size, why wouldn't I just get a RatRig 500, put it on the same wheels, and have an even larger machine that is more robust and right about the same cost? That's kind of where my thinking was on it. What I'm doing now is I'm just generating tension graphs for the different tool heads. Just working to evaluate that the belt tensions are the same. Nice. You have a 400 millimeter bed flinger to unbox today. Goodness, that's gonna. I mean, I had an Ender 3 Max, and I sent that over to Shannon Rona so that she could use it when she was starting to rebuild her Iron Man suits. But I couldn't imagine a 400 size bed slinger. That's an insane amount of weight to be moving around. But yeah, I mean, looking at the costs and stuff. Sorry, I'm hearing something rattle, and I'm trying to figure out if it's just something in the back. No, it's something on the tool head. You know what? I wonder if it's the ball in the sensor rattling. Can you get a RatRig 500 for $12.99? So RatRig V-Core 4. I should have went. Is this the store? Yeah. So RatRig V-Core 400 or V-Core 4. Let's go with a 500 pre-configured. So this is a full kit, right? So V-Core 4 500. So if we want to do it and just say, okay, 400, so it's 1,800 US dollars, right? But I'm a 3030 frame, and it seems like it's going to be a little more robust. There's an IDEX upgrade, a hybrid motor upgrade. There's a lot of things that you can do, but if I do a 500, who cares about the LEDs? Do a hybrid upgrade and an IDEX upgrade. And for gigs, we'll throw in a RatPack. So all in 2722. Is it cheap? No. Is it going to be more reliable and from a brand that's known a lot better than everyone? I mean, I don't know. I trust the RatRig and the RatRig brand a little bit more right now. You had a Sobel 500 bed slinger. It was a disaster. Yeah. You're going to try and print the 180. Oh, got you. You're going to do the RatRig chunk. The V-chunk. Yeah. See, that's the thing is I can't do the V-chunk because this is the 300. I need a 400 to do V-chunk. Because I want to do V-chunk. It's kind of a cool design, but yeah, it's I want to do a V-chunk, but I'd have to have something bigger. Right now, my biggest bed size is 370 by 370, so I can't do it. So maybe I'll commission Zombie to build or to print me the V-chunk parts that require the 400 millimeter bed. Okay, so now we've got the two belts graphs, and we'll try and look at these side by side. Once again, this was X only, but running the two different tool heads. And by running the two different tool heads, you're basically running the two different belts, right? Because each tool head is on a different belt path right now. So what we're looking for is, are we getting same spike range? Yep, it's doing the same little whoosh, spike up, come back down. The one's doing a smoother down. This one has a little bit of a bobble, which could be swing. A little over the 125 range, we have that precipitous drop. And then we start cruising back up in the 200 range. So yes, these are about the same. There's a little bit of concern right here. That's 75. So let's look at the manual and see what it was telling us about that again. With the, I'm not going to call it a spike, but it was a dip. So with the issue here of a slight swing in the front and a dip in the back, the vibrations are zigzaggy points, where swing is more of a smoother texture. Because normally that it sits on a uneven surface, a shaky table. Yeah, it's sitting on a 40-40 table, so it's probably not that, but it is on carpet. And like I said, what we're seeing right now, I'm not too concerned. And do I need to put the, okay, we're going to, yeah, we're going to give this a shot. We're just going to tell it to do generate shaper graphs and see what happens. Maybe get our button up on the emergency stop real fast. Let me close some of the extra stuff out. So generate shaper graphs. Yeah, I kind of don't like that it's doing it right at the front, because it's going to start slamming into the front when it goes to do Y again. I have a feeling. Thanks for the lurk, zombie. Oh yeah, got you there. A bit nuts. Yeah, it's a flying gantry similar to a Voron 2.4. Where the RatRig is more like the Trident. But like I said too, the RatRig is beefy, right? It's got the HG15 rails in the Z. It's using MGN12 on the X, Y, and Z, or excuse me, X and Y. You have the option for IDEX on it. You know, it's apples and oranges, and I get that, but I get concerned with a company, and there's a lot that are doing this, where rather than do a pre-order, they do they do Kickstarter, right? And I'm also getting annoyed with Anycubic did this, and Elegoo just did this, and I've seen this with Creality too. Of, you know, boom, we launch. They've had everybody out there doing hype. Boom, they launch. And they got a very small batch of batch one printers, which turns everybody, basically, if you're not in and within the first 5 minutes, you're now into a batch system, and it's months before you get the printer. Yeah, I'm going to stop this because I think I just need to put the tool heads in the middle before we do this. We'll see. It's just a little concerning to me when running that. Yeah, I know I can change that so it doesn't do that very, very loud, ramping up both the 4028s. But you have to change something and flash the board again, and I'm too lazy to do that right now. So we're in the middle of the printer. Now I'm going to tell it to generate shaper graphs and see what it does. I'm not sure if it'll. Well, it looks like it's going to do X and Y. All right, there. Well, okay, so it did Y. Now it's doing X, and it's the way that the. Yeah, we're going to stop this again. So the problem that's happening is it's running the motors. Give me a second. Okay, and this is why it feels like something's wrong, because I am in the IDEX guide up here and it's telling me to run scripts. I'm not seeing scripts, right? And I feel like as it's running these, it's got, yes, it has updates for drop downs where you can tell it what toolhead, what axis, but it's as it does the homing to do that, it's using the core XY belts to do the homing. And as it's doing that, it's moving both tool heads. So it homes Y, brings everything to the front. Then it pulls it back and it goes to home X. And as it does X, it's slowly pulling it back to the front. And I think that's going to skew these graphs. So I think something may be weird. I don't know. We'll try this. Just going in and manually saying generate an input shaper graph. For toolhead 0 on X, and we'll see what it does. No trigger on dual carriage after full movement. Move those slightly in. Try that again. See how it's moving forward and it didn't trigger this all the way. Now it does this and now it's all the way forward. So when it shakes X, it's all the way forward versus being centered. And you really want this centered in the build volume, not right at the front of the machine. So I'm kind of concerned about that. And this is part of the IDEX where normally you would have the X and Y belt connected to the tool head. So as it's doing the movement, it's keeping the Y position. But when you've got IDEX, it's kind of moving it in Y and X at the same time. So I don't know. I'm just confused. Like, I'm wondering if there is supposed to be a script that does something and it's not installed or something. Um, Because like all of this here, nothing is saying about putting the belt back in or the V belts back in yet. Do calibration. I'm going to scroll back up here. I'm wondering if I was supposed to put the V belts back in after doing the please note, hybrid steppers will be ignored as they should only be installed later in the guide. Okay. Okay, so that got us a shaper graph. So won't let me move it. That's fine. So let's try download that. Let's try the G0 in the y-axis. And there's where we just slammed into things. That's the part that worries me, because that's going to skew the results. Guess what I'm looking for is I'm trying to figure out where and when it tells me to install the Y belts. Because I don't know why you would do input shaper without having the hybrid Y belts. And if you go through and do the calibration for VAOC, as soon as you put the Y belts on, that would change things, I would believe, and you would have to go and do that again. Let me go full screen here as we dig through this. So for skew correction, you have to print something. Yeah, there is nothing here that tells you to go ahead and put the Y belts back in. So how about this? We're going to put the Y belts back, because this makes zero sense to me right now of let's do this without these belts in. Let me do a $18. We move this. And I think once we get this put back on here, we'll get a little bit better input shaping, at least process going. Okay, so we go around this one, or around that idler, around the pulley, back around the pulley, around the rear idler. Grandmother's house we go. That's tweezers. So once again, what's everybody got plans for this weekend? Like I said, I'm not going to be streaming because I'm going to be helping Echovate with their move. But I hope everybody else has some plans. You should be able to catch like a Lee Marie stream or somebody on somebody else on Saturday. Not a bad belt path, but it's, once again, once you get panels and stuff on there, then it gets a bit not daunting or annoying, but yeah. So do that, we do this. With me, not against me. Come on. Lee Marie is putting together their death racer, if I remember right. Something I need to start doing is printing parts for Mrs. Dragon's death racer that she wants. So we got another Big Tree Tech kit. So Evil Diesel has started printing parts for the KB3D death racer that we're doing for them. And as soon as that's ready to go, we will start. Well, he's got to send me some files to print because he can't print them on his side because we need an IDEX or something to print it. So he'll send that stuff to me and I'll print. And then we'll do I'll have to start doing the files for Mrs. Dragons. I think the base and the wheels and stuff like that are all the same between the variations. It's just more of what are you going to do for the side panel decorations and which front end are you going to do and so forth. Okay, so one side back on, come over here and do the other side. Same thing. See which way I did took the belt off. This way. Same type of thing. We go around the inside of the front idler, around the pulley. We have to go around the back side of the rear idler. Then it gets fun just trying to route a belt that's already got some kinks in it. Make sure you're at the pulley and not, or yeah, the pulley and not at the, that you don't go around a standoff. That will mess up input shaper grasp, by the way. I would say ask me how I know, but hopefully you've figured that out by now. You make sure that your belts are lined up on the pulley and the idlers, and that nothing's riding up or down, especially before you go to tighten these up. And if you want to see how the belts go in here, I'll try and find the previous video where we did the belts so that you can pull up that and look at it. For now, I'm just getting them back in there based on, like I said, the previous, we'll say, memory bends in the belt from being in this P-shaped position for so long. These, I will say that you can put a good darn amount of tension on these belts and they're going nowhere because of the way these belts wrap around and interlock. If you're going to break a belt or shear a belt before it's going to come loose out of this block, I would. We're going to make sure that we've got both belts on. Like I said before, we unscrewed each side 3 turns, and the belts are fairly loose right now. When we go to tighten them back up, before we tighten them up, we want to make sure that the alignment of the belts vertically, like I said, on those pulleys and idlers is good before we go through and apply a lot of tension to this, because the last thing you want to do is have a belt riding up on a pulley edge and apply a bunch of tension, and you're going to over tighten it, and then you may have an issue with your belts. And I'm sorry, I just did this and you guys were on the completely wrong screen to even be able to see what I was doing. Well, we got these put in. I'm going to make sure as I move this front to back that it's tracking in the belts and the idlers, which it was not. Turn it. Tracking here. Seems to be tracking there. Now what I'm going to do, we had put 3 turns, or we took these off by 3 turns. So what I'm going to do is 1, 2, 3 turns. Returns. Feels good. Go ahead and make sure that everything is still lined up and moving freely. We'll need to tighten down our locking screws, nut screws. And now still needs to have its thing added to it. Oh, what? Oh, it tracked me. Did you track me? Either it tracked me or there we go. All right, so we're in the middle. Let's go ahead now that we've got the V-belts on, and we'll just hit generate shaper graph and see what it does this time. All right, see how it's not moving forward and both tool heads aren't moving at the same time as it's trying to do that? Now that makes more sense. There we go. That's what I was looking for. The other machine that I was interested in, the Airy one's a 400 size machine, is the Ender 5. Was it the Ender 5 Max they just announced? The thing that annoys me with that is it says enclosure available. It's not an option to select when you buy the printer, and it's not an available accessory that you can find today. So that is kind of annoying, because if I'm going to get a printer that size for my use case, I want it to be able to be enclosed. So that's kind of annoying to me off the bat, because it doesn't fit my use case. Similar thing with the Anycubic. It's got manuals to tell you how to replace your extruder and your hot ends. You can buy additional hot ends, but none of them are hardened at the moment. So you can buy additional standard non-hardened hot ends. And if you need a new extruder, you're going to have to go and open a support case, because there's no extruder listed on the website. So that's the other thing, is you're releasing printers without basic replacement parts in case something is broken or borked from day one. And that's just a bit frustrating. All right, now it's doing the y-axis, so this makes a lot more sense now. So it's the commissioning guide is not telling you to put your Y-belts back on. Just checking again my belts and how they're riding up or not. So I believe once we get there, there is a suggested print, which would be the, I think it's like a 2-color benchy. I'm sure there's some other things that'll be available as well. And in fact, when I go to print the parts we were looking at that are going to need dual color stuff, I may wind up doing it here because it's only going to be 2 colors, and it's going to be the TPU parts. So I could run spools hanging off the top middle rack, or I can run some spool holders on the sides here with a very short direct drive into little stubs of PTFE. And I think that would work a lot better than, say, trying to do it on the black box, just because of the way the PTFE tubes run on the black box. It'd be a little bit harder to bypass them like that. That would be something I'm going to look at. Are there any other printers coming out that people would be interested in seeing, or printer builds? Like I want to do a Prusa 4.1, but I don't want to do a Mark 4S conversion, or Mark 4S conversion. I want to do an actual 4.1, because for one, I only have a Mark 4. So I'd have to do the Mark 4S upgrade, or at least buy the Mark 4S upgrade, and then do the Core 1 kit. But I feel like there's a lot of the Mark 4S that does not get used. Like, that whole aluminum frame and the 3030s, I don't believe are getting used when you do the conversion. Right? Yeah, you're using an extruder and some printed parts possibly, but there's a lot that doesn't get used. And I would much rather have a Core 1 and just build it from scratch. That's me, I guess. I'm a glutton for punishment, and I like doing machine builds. Lost Ink, how's it going? Welcome on in. So I'm standing behind the camera, basically. We're doing a input shaper. I was getting a little frustrated trying to do the input shaping because, well, it told us to take the V belts off, the hybrid Y belts. So these belts off to do the belt tensioning and run the belt tensioning scripts to make sure the 2 X belts are installed properly. And it didn't tell me to put the Y belts back in. It just went into input shaping. And as soon as you do that, it starts smashing against the front of the frame and everything. So as soon as I put the Y belts back in, it got better. Yeah, in this right tool head, there is a vibration, and it really does sound like it's the ball vibrating in the tool head. I will go through and double check all the screws, but Yeah. You know, the interesting thing too, as it's doing the resonance testing, there is not a beacon probe on toolhead 1. So it's running this toolhead, but the sensor is over on the other toolhead. I'm curious to see how that works. Well, I mean, that's the thing is I would have to do something with the remaining parts just because I would feel bad doing it. Now, once again, if I want a core 1 and I want to build it, I'm going to choose to get a full kit and build it because I have not upgraded my Mark IV to a Mark IVS. So I would have to upgrade to a Mark IVS before doing the Core 1 conversion. Okay, so we've got input shaping graph. And is it graph or graphs? Yeah, there we go. We've got a few sets of graphs. We'll click these and get them downloaded. So we've got tool 0, X and Y, and tool 1, X and Y. So let's go with tool 0, X. So once again, this is the tool 0, X graph. And what is it telling us about? We'll go back to full display now. When we run these graphs, there'll be 4 files. The name should be intuitive. Yep. T0 resonance Y, blah, 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 is the T0 Y axis input shaper graph. Yep, yep, yep. Open each one of the graphs and record the values for the T0 X resonance, T0 Y resonance, T1 X resonance, and TY resonance. So basically open all 4 of the graphs. So what I'm going to do is downloaded 4 graph files, X, Y, X, Y. Yes. Do that. Really? Open. Open says me. Are you serious? I wanted you to open all 4. That's T1X. Open. 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 Okay. T1 Y. 0X. 1X. Delete. Okay, so X's and X's. This is the T0X. And this is this had 8. Now I see what T1X. Okay, so it says to grab the what parameter? Grab all 4. Okay, so we're basically going to look for the input shaping protocol, the frequency, and the maximum rate acceleration. So I think what we'll need to do is a little notepad plus action here, and we're going to collect some info. So what was that? So we've got info from sit over here. Grab that, grab this. From the T0 graph, T0X, DV 59. Actually, what is its suggestion? MZV. So 57. MZV percent Excel 9600. Seems like a low Excel number. T1X. Suggestion there was EI. Okay. I like to try and keep the things close, but okay. $39.2. Yeah, not 39.2, 53.8. 0.0% at that one. That's kind of good. And Excel, $5,400. Seems way off. E0Y. Now. and also see if anybody's chatting. So T0 is MZV. MZV is 59.4 hertz. Vibration at 59.1.8%. And acceleration 10,400. So interesting, the right hand, not too much, a little bit more. T1Y, just MZV. At 59.4. Those are T0Y, and that's T0. All right, let's use now. Why are you not showing what is going on here? T0Y. Okay. T1Y, recommending EI. EI number is 53.8. Okay, so interesting numbers. But what are those numbers mean? And I think we're going to need to be collecting some more. So what are the numbers? And they wanted the input or the protocol, the frequency, and the maximum recommended acceleration. Interesting that the Y on both of those was way slower. But now what it wants us to do is IDEX copy. So what we basically just did was IDEX single. Now we're going to do IDEX copy, and we're going to do the same thing to generate the graphs. Now in copy, the IDEX toolheads will be moving in the same direction as you just saw them do there. So in copy mode, they're moving left side to side together, right? So they're both moving left and both moving right. They'll move in Y together. When they're doing copy, they'll be moving in opposite directions in the X and the same direction in Y. That's why we have to do the different modes and run these tests over again. So now you see that both of them are running together versus running one than the other. This should give us completely different input shaping graphs because of the way that they're running. Well, yes, right now it's copy mode. So this would be like if you had a figure like a mini Wexter and it was facing to the left, both of these would be printing facing the left. If one was facing the right, or in mirror mode, one will be facing the left and one would be facing the right. Yeah, that is definitely something loose in that right tool head. I will double check all of the bolts here, but I seriously have a feeling that it's the ball bearing in the filament runout sensor. You'd crash it. Well, that's what was happening, Chewy, was it kept crashing, and what it wound up being is in order to do the input shaper, you have to have the V belts on. Or excuse me, the Y belts on. If you don't have the Y belts on, it's going to move itself cattywampus and not be centered in the Y direction. So it kept slamming against the front of the printer. Be a bang where there shouldn't be. Well, we've tested all the movement already. That is one of the first things you do in the commissioning process is make sure that things move in the proper direction when you tell it to move in a direction. And you're doing that in 10 mil. So you do an M18 to shut the motors off. You get them kind of positioned like they are now, and then you do a 10 mil move left or right. And so that way you can tell, like I told it to move left, it moved left. I told it to move right, it moved right. That belt's good. And then you do it for the other tool head, and then you do it for the Y as well. And make sure that everything's working good. So remember in the hybrid configuration or the standard Core XY, both of the rear lower motors are moving the tool head, the single tool head, in the X and Y direction, right? Now in the IDEX configuration, the left lower motor controls the X direction of the left tool head. The lower right motor does the direction for the Y tool head for the X. And that's where I'm saying is as they start to move, they can pull the Y out of position, which is why you have to have the hybrid motors to maintain positional accuracy in the Y. Gotcha. So the IDEX stuff has not been put up on YouTube yet. I did that specifically for a reason. I'm just slow rolling. I'm behind on getting stuff put up to YouTube, so I'm trying to slow roll and spread it out. So I'm releasing videos on a consistent basis versus, hey, let me dump 6 videos on the same day, type of thing. They'll get over there. They'll just get over there a little slowly. So what it's doing right now is it's funny because it's running a T0X or excuse me, a T0X, a T0Y. Now it's running a T1X, T1Y. But once again, there's no beacon on the right toolhead. So it's pulling the data from the left toolhead even when it's testing the right toolhead, which doesn't make sense to me. Like it's almost like you'd want to batch it and run the individual commands and do the X and the Y for T0, then physically reroute or like move the beacon over to toolhead 1, but you don't have enough slack. If you had a spare beacon cord though that you could, well, it'd be a pain in the butt. You still have to drop the bed to get to the screws and stuff because it screws in from the bottom. But that would be more accurate to be running it from the actual printer, or I'm sorry, from the actual tool head. That's on. So interesting, funny story. So as I said, I printed the parts for the RatPack in 3DO, AS or was it 3DO, carbon filled, ASA, and RatRig green. And I say funny because when I was at Rocky Mountain last year, I was talking with Hector, and that's where I talked to him about getting the sorry here, folks. That's where I talked to him about getting the RatRig, and we made the connection and deal to do the RatRig build. Sorry, give me 1 second. I'm looking for printing temp. Okay, cool. So the PC ABS blend prints at ABS temp. Good. Like, why is that not going in? During that show, they had a Batis cocoon, and he gave it to me. He goes, it's not a dryer, it just holds desiccant. So it's just more of a desiccant container that will dry filament. You have to dry filament and then put it in there with desiccant so that it stays dry while you print. And I was like, oh, well, I was going to take a look at it, but if that's all it is, he goes, here, take it. And he gave it to me. I said, well, hold on, there's filament in here. Let me give you this filament. And he goes, take it. That's how I came up with the 3DO ASA, it's glass filled, RatRig green. And it pretty closely matches the RatRig green of the parts that came with the kit. So that's why I did the RatPack parts in. Okay, so we did another set of graphs in copy mode. So bing, 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 bing. And now it's going to want us to do it in mirror mode. So we'll click on mirror. And now we will run it again in mirror mode. And once again, this should have those two X tool heads moving opposite each other. Hey, Royal Nomi, how are you doing, dear? I hope you're feeling okay. While this set's running, I'm going to open up the other four graphs and I will collect the data from them. So let me do. I'm going to step in front of this real fast to sit down and try and copy some numbers. Hurted my knee. Mostly overwhelmed. Can I can understand that. I can understand that. E0x. 0 copy X was Z Victor. Z Victor would be 51.4. Vibration at Z Victor was 0.9%. Cell 1,300. And that was a nice peaked graph there. Same thing for T1X. Z Victor. Sorry, folks. I'm trying to copy down some values real fast. Um, your sisters will be, oh, your sisters will be there for the week. I'm doing pretty good, Royal Nomi. We're playing around with the printer here. We're getting it to make, you know, move and move in the right direction and do cool things. I'm hoping tonight that, we'll be at least set and ready to go so that next Tuesday when we stream again, or I don't know, maybe we'll stream at a different time Saturday. We'll see how I feel, but I'm going Saturday to help Echovate 3D move from their old store to their new store where they're tripling their floor space. So I'm not going to stream Saturday morning. They're going to be moving Saturday and Sunday, but I'm hoping that we get some people there to help, then we might be able to get everything moved Saturday. So it's just rearranging stuff on Sunday. And really, I don't have to be there, but I am choosing to be there to help out. Oh yeah, that's starting to make some noise. That's making some noise. I think our IDEX mode and copy or mirror is going to give us our best speed and input shaper stuff. Hey Glendon, how's it going? We're watching the IDEX do its input shaping. We have to run it as independent tool heads in copy mode, so where they're moving in X together. And then we're doing mirror mode now, which right now it's doing the Y, but in mirror mode, the X's are moving in opposing directions. So they're going towards each other and then away from each other versus moving both to the left and to the right together. So that's kind of what we're working on right here, is getting this going. Just trying to figure out some Excels and stuff like that. Boy, figures right when I move there is when it's going to get done and it's going to go into processing, right? Yep. Okay. So while it's doing the processing, we're going to come back over to full display. And let me pull up, like, we got E0X. So this is the X for tool head, the left tool head, which actually has the beacon probe, right? This is exactly what you want to see. Single spike comes down, very little bobble, and any bobbling needs to be smooth, not jagged. If we look at tool 1 in the Y, this will be the tool head on the right, which, as I said, the beacon probe is physically mounted to the left tool head. So when it's measuring this movement, the sensor that's sensing is about 120 millimeters to the left of the tool head that's actually moving. So once again, you see a spike right in the same spot. One's kind of spike up with a downward right drop. The other one spikes up with a upward right. So it's kind of a mirror of each other. And then we see it drop back down and we get a little bit more bobble here. Once again, I think this will get smoothed out if the sensor was on it, we wouldn't see this little dip rise here. And when you see the gentle curves like this is what they refer to as swaying with the axes. So, but those two look really good together. Once again, in both cases, this was both tool heads moving in the same direction as it's doing the input shaping. Okay, now we're going to look at the Y's. There's T0 and then T1. So this is the right tool head. This is the left tool head. And as they are moving in the front to back range. Now, once again, they're both on the same X gantry. They're both moving front to back at the same time. So I would expect these two to pretty much mirror themselves in what's going on. So once again, very good graphs here. There is this front spike at low resonances. And it's pretty interesting that here in the 125 to 150 hertz range, it pretty much zeroes out. Like the curve has zeroed out on these. But we are getting really good graphs. They are saying Zulu Victor, which is 12.8 on the acceleration. So that's pretty good high acceleration. Now let's go and I think I clicked on the graph. So we have a third set of downloads. Copy? No, we haven't pulled the mirror graphs yet. So we're seeing some double spikes here. Once again, I think that double spike is because they're mirroring each other, which means they're going towards each other and away from each other, which is going to add a lot more induced vibration and resonance in the system. Let me do T0X. And T1X. Once again, these are the two tool heads moving, I'll say, against each other on the axes. So this is, we're getting a really good, no, that's copy. I don't want copy, I want mirror. Yeah? Okay, there we go, mirror. We need to basically refresh. So T0X and T1X. These are our two tool heads basically opposing each other. They're not quite canceling each other out, but you're seeing the dual spikes are all in the same spot. Everything kind of evens out. And they're saying EI here, so a lot slower on the acceleration when doing copy mode. Or I'm sorry, not copy, mirror mode, where they're fighting each other. Right? And I'm really going to have to look into these graphs. And I know everybody that has been doing their input shaper graphs there's a lot of chatter about the input shaper graph. I would expect the Y's to be, I'm not sure why we were getting a second spike on the Y's, because these are two tool heads moving front to back. They weren't moving in the X direction as they were doing this. So I don't know why we're seeing a double spike here. Once again, Zulu Victor, 57, 57.4, 2.3, 2.7 vibration, Excel's 12.8. So yeah, that the Y here is really measuring the same way we'd expect. So yeah, I'll have to dig into these a little bit more. I'm really not sure, but I'm not seeing major weirdness here. And what they're looking at us to do is to capture all of this data. And basically we're creating an array. So shaper for X. So the frequency for X, T0X, T1X, then copy X and mirror X average. Yeah, basically we're setting up an array so that depending on what mode we're using, it can select the right combinations. That's why we're collecting all that data. Okay, Nomi, please lie down and rest and take care of yourself, sweetie. Please. We need you around. We want to see you this year at some chilling like a villain, by the way. Chilling like a villain. Okay, so we've got that stuff. I'll have to pull the rest of the information to set this up, but basically it's we did this for what are we doing? We've got oh yeah, independent X or independent tool 0, independent tool 1, the average of the for copy of X and copy of Y, and the average of mirror X, mirror Y for the frequencies. That'll be easy enough to do. And of course, max acceleration would be max accel will get added in. Now it would be setting up our VAOC calibration. Yeah, we should be able to do that without doing the input shaper. I've got to make a note that to do the input shaper array. Yeah, no notes. Let me actually get that information because otherwise let me do it before I forget, and then we don't have it done. You sit here and see my half balding head. So let me pull up T0X, T1X. Pull up my sheet here. So T1 is EI. .484. And the cell at EI is dismal. Now you don't want to mix your your frequencies, well, not your frequencies. You don't want to mix your input shaper types. Like you don't want to do MZV for X and EI for Y. That it does not like that. It adds additional compute strain and it doesn't like it. So what I'm going to look at is here, see what those vibration numbers are between the, like I'm seeing currently X is EI, right? So the EI vibration numbers are low. 0.2 on this head. And that acceleration winds up being a dismal number, right? But when we go to the Y's here, I'm minimize it. When I go over to the Y, so T0, Y, work with me, and T1, Y. All of a sudden it's talking Zulu Victor, right? So Zulu Victor, 57.4, vibration of 2.3, and 12.8 for the acceleration. So on the other one, should be pretty close to the same. Zulu Victor, 57.4. Vibration on this one is 2.7. And the acceleration is 12.8 or 12.9. 12.8. So we're seeing some good numbers here on the Y when we're in copy and mirror mode. We see on the copy mode where they're working together, we've got beautiful graphs and we're getting good acceleration numbers and stuff and low vibration. When they're in mirror mode, we got low vibration, actually a lot lower, but we're on a different graph here. It says EI is the best. But we can't mix. So what we need to really look at is, what if we do X and X? What does ZV look like here? So ZV, if we go with ZV, vibration is 5.6. Okay, that's getting a little high. And Excel is 1300, or excuse me, 13,000. So we get up in that range again, Excel wise, but at a higher vibration. And that's on toolhead, the one toolhead. And if we go to the other, vibration of 7%. So there's a high vibration when they're going against each other on the X if we stay in the EI range. So for X, it wants to go at a slower acceleration point, and Y, we can still go high. And if we go into that same acceleration point and using Zulu Victor in there, we're going to gain a lot more vibration. So we need, that's the kind of the things that we're needing to look at. Yeah, basically, I think we can get down into a 0 vibration in the Y, but it's also killing our our accels to do that. On the X and Y up here, once again, our Y, it keeps wanting to go over to EI, drop the vibration to nil, but it also drops the acceleration way down. So we're going to have to look at that and play around with those numbers some. And that's where I'm saying is I think what I'm going to do is wind up doing Zulu Victor here, which would be 57.8. It would be a higher vibration, 5.6. But it gets me back into that higher acceleration point, which is kind of where we want to be at. And we won't push that acceleration either. And that in and of itself will reduce the vibration some. Meaning we're going to put a max acceleration in for the printer. And what we're going to do is we're basically going to underwhelm it, right? So for X, we're up at 10.3, 12.8, 13, 12.8, around 10. So I think if we put the acceleration around 96 or 10, we're going to get there, right? Because we're going to look at making our numbers match a little bit better. It looks like we're going to go ZV just about everywhere. I'll probably look at the original ones and see if ZV gets me that compromise for the main tool heads. I think that's what we're going to do. And I just talked myself out of doing that. We're going to go ahead and run the VAOC stuff. So home and perform a Z-tilt calibration. So let's go back over to the browser window view. Hey, there's chat. There's chat. Let me see chat here. T's and P's for you. Yep. Looks like your EKG. It might have. Are you going to put a camera on the RatRig? Maybe. Maybe. I think I have seen there is a RatRig mount that I saw somebody had that puts a camera. I think it was mounted right here to this side rail and looking over. And I've also seen one where you can mount it kind of top center looking down. I'll have to check it out and see which way works best. So we're going to copy this, wait to sneeze. I'm going to home it and then Z-tilt, home all. Now we're going to do a Z-tilt. Hey, Hutchmaker Space, how you doing? Yeah, so I've got another 3DO camera. I think it was actually a nozzle cam, but it's the same camera. It's just pick a housing, right? It's so I may put one of those in here. So it said to do a VAOC reset. And by the way, it is pulling in base input shaper stuff. So that's why I need to add that. But VAO configuration resetted. Please calibrate before using the printer. That is the plan. We need to do an M84. Extruder already active. Extruder now syncing with extruder. Extruder 1 now syncing with extruder 1. Got shaper types. Okay, that's great. Now navigate to the VAOC tab and hit Start Calibration. Okay, I'm going to scoot around to this side and let me bring you all around here, because this is where the magic's going to happen. The VAOC is this right here, and it's going to do XY. It's going to light this camera, and it's going to be using that, or light that ring, and it's going to use that camera to look at the nozzles. So we're going to navigate to the VAOC and hit Start Calibration. So we're going to come over here to the VAOC tab. Reason is there's the light on. Okay, and we're going to click Start Calibration. And I hope it knows what it's doing, because I don't have an emergency stop now unless I go back to mainsail. Apparently it's going to home the printer. Okay, so we're a little bit off, right? So now it tells us T0 is automatically selected as the main tool head. We advise flipping the camera movement right away. This makes adjustment easier, but it's personal preference. Measure the external diameter of your nozzle with a set of calipers. The standard Vetus nozzle is 0.1 millimeters. Insert the value in the setting window. Adjust the pixel rate so the nozzle hole matches the crosshair size. Okay. So settings, nozzle diameter 1. Okay. And I'm just going to look at theirs because I have no idea. 330. Up horizontal. So I just did what they said to do. Okay. I'm assuming a 1.0 nozzle because I'm using the default. Adjust the Z position to the right to achieve a clear focus of the nozzle. Then drag the nozzle hole to the cursor center. I have no idea what that just. That's done. That's not what I wanted to do. Calibrating the Z offsets, by the way. even though my nozzles aren't lined up. Okay, so we're going to try. Why is it? I don't know what. Go there. Okay, let's try this again. So adjust the Z position to the right. Where are you getting the Z position? Z focus. Okay, that makes sense now. Okay, and hold our settings. Z focus. Um, right direction. Can't tell if I'm high or low here. That seems to be getting out of focus. Getting closer into focus. Do that. Back here. Up, going that way. How do I move? Adjust it to the right to receive a clear focus, then drag the nozzle hole to the cursor center. Drag the nozzle hole to the cursor center. Close, but not there. Looking at theirs versus mine, can't tell if now I'm too close or not close enough still. Come on now. I guess what I'm trying to do is figure out how close to be to get the. I think that's as close as I'm going to get. Okay, so we're there. Now click T1 and align the nozzle with the crosser. Change from T0 to T1 2 to 3 times to perfectly align the nozzle. It's normal if they drift a bit in the first few attempts. Okay, so let me go full display while we're doing this. Okay. So I think we're pretty much there with the nozzle lined up on that center there. Now if I go toolhead 1, okay, drag this up so that the pretty good there. Hopefully everybody likes that. I think that's pretty good. We will flip back to toolhead 0 and see how aligned we are. Slightly off. Toolhead 1. Now remember it says to do this 2 or 3 times to make sure that we're centered. I think we're slightly to the right there, so switch back to toolhead 0. Like I said, we'll just keep doing this back and forth a little bit to make sure that we get it fully lined up. By the way, so toolhead 1 looks a lot, I'll say dirtier or whatever, because it has been printing, and that looks pretty darn well lined up. Magnifying it to 2x. Looks pretty darn lined up. That looks pretty darn lined up to me. What do you all think? Is that lined up? Because I think we're lined up. Um, Once you're happy with the nozzle alignment, click on the square icon to the top left to end the VAOC. Okay. Once you're happy with it, run the following command: calculate DC end stop. Have to go back to mainsail to run that. Okay, and it just spit out a bunch of lines here. So we're going to grab this, copy that, and it says to copy and paste to your printer config. Um, Copy output and paste at the bottom of your printer config file. Okay. So I'm just going to click down here on the bottom section, scroll down a little bit, and right in here, we'll add in the dual carriage position, um, variable for the bed margins, blah, 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 and the offset between the two tools, sure. Save and restart. And basically, we're going to make a new VAC nozzle alignment and run through these steps 5 through 8 again. All right. So home all, we Z-tilt, and then we run the procedure again to validate that our stuff took. What I'm saying, we might be printing within the next week. Really need to fix that. Good work. I need to fix this one with my with the spring steel again, and probably pull those wires through a bit. It's a little bit longer than it needs to be, but I'll do that off camera. VAOC reset. Going to VAOC. Settings, blah, blah, blah. That's good. Start calibration. Move everything over. We should be on toolhead 0. Get our focus in. Okay. And we're going to do the same thing over again. So we're going to take this, line it up right there. Okay. Now we'll go over to toolhead 1. Off. What do I need? I'm going to zip tie these two cables together just to make sure that it's not like falling over and causing part of that problem. Everybody hanging in there with me? It's that. Getting close to very minor corrections again. Hopefully we're getting dialed in. Looking close enough for government work right there. Thanks, Eagle. Yeah, that's looking pretty good. That's good enough. I mean, that's going to be good error. Yeah, that's going to be close. So it said to run 5, 6, 7, and 8 again. Okay, so let me actually run 9 again. Okay, so make a new copy output text, put it in there, good. Do this, run the command, make the validate the calibration. Open the variables config file inside the machine tab and check the IDEX offset value. When the RatOS variables config file and look at the variables for the X offset. The value is higher or lower than 1 and the printer suffers from a mechanical issue. IDEX X offset. Well, we're at negative 0.07. I think we're good. And it didn't mention looking at Y, but looking at Y, we're at negative 0.3. So we're still good. We're under a 1 plus or minus. So we're good. ZN stop check and calibration. Both nozzles should be at the same height. This is impossible to achieve in real life due to machining tolerances, blah, blah, blah. So we're going to compensate. Home and Z tilt adjust. Close this. Back up here. Home and Z tilt again. This is fun, I think. Z tilt. Once again, it's only using the left tool head to do this because it's the only one that has the baking probe on it. And it should be within tolerance on. Hey, look at that. It's 0.21 hundredths, and we only want, or 2 1,000ths. We want 2 100ths tolerance. So we're an order of magnitude higher. Said to go into the VAOC, calibrate the XY offsets for T0, T1, and then hit calibrate Z offset. Okay. So, yep. I mean, now I'm just being nitpicky. Okay, good. So calculate or calibrate the Z offsets and then hit the calibrate Z offset. So this is where it's now going to go and do the Z height on the little uh, end stop button there. And, and because it's realigning the two tool heads together, it's going to make sure that when it goes over to do it, that it's hitting right in the middle versus the side, because it's not a 100% flat top on that Chicago bolt, I don't think. Okay, click on the square at the top left in the VAOC, navigate to the machine console, and observe the Z offset value between two. So that we'll go back into main sale. Okay, here's our high tool head Z offset of 0.090938 millimeters. Um, value should be smaller than 0.07 millimeters. So I'm high. Your Z offset could be better. Use minimum 0.3 millimeter first layer height for copy and mirror mode prints. Okay. How to improve your Z offset? If your value is larger than this, you need to check if both tool heads are correctly assembled and everything is tightened down. Please go back to step one and redo the testing. Check if the values from different tests are consistent. If the values are not consistent, it would mean there is a mechanical problem like a loose nozzle, loose heat break, screws, loose lead screw. Okay. So in this case, it's saying because it was a negative, right? Or no, it's positive. So that means that the tool head 0 is lower than tool head 1. The easiest fix is trying to loosen and retighten both nozzles. Hmm. Hey Jerry, how's it going? You started your box turtle yesterday on YouTube. Awesome. That is awesome. So where we're at right now is our Z spool head heights are off. So what I'm going to do is drop our bed down and positive number. So tool head 0 is lower than tool head 1. Okay, so we're going to do a couple of things. One is I'm going to come over here and try and tighten some screws because it seems like there's something vibrating on the right tool head. I'm just going to make sure that things are snug down there. So how is the box turtle build going? And actually, I just did that. And I think what I'm going to do is, because this side is lower than this side, take this off, throw the screw around, and I'm going to have to take this screw out. What I'm going to do is just make sure that the tool head is snug. And the easiest way to do that is to just lift the extruder up and off. And you need to take out this right screw because it's the one that's connecting it to this back plate. So you take out the right screw, drop it on the ground or somewhere. Like fun. I literally have no idea where that went. It didn't make a big noise, so that tells me it hit something soft. Okay, there it is. We'll take the other mounting screw out. So with the tool head being lower on one side than the other, it could simply just be that the screws aren't as tight as they could be. So that's what I'm going to do is I'm going to take my make sure that everything is tight. And these are 1.5. Is there like M2.5? And those are tight. So now we'll put this back on. Line up and sit back down on there. And we can go and we'll take the nozzle and heat break. We'll loosen those up and then reseat those, and we'll do that on both sides. And we'll run our test again and see if we're any closer or if we made a difference at all. Because once again, they're going, it's physical difference in the nozzle because they're at the same location on the rail when the test is being done. So it's physical in the stack here, and it's really from this plate riding on the MGN carriage and down. I was just thinking if something is loose up here that it could be allowing it to sag a little. I don't know. Doesn't necessarily make sense to me either, but we never know what little tweak will adjust something, especially when we're talking about, we're trying to get from, what was it, 0.9 down to 0.7. So we're trying to literally get a 0.2 millimeter difference. Hey, Winsing, how's it going? Welcome in. Hey, Free Heathen, what's up? Yeah, that sewing machine project is going to be really, really cool. I'll try and move you guys around here a little bit closer so you can see what I'm doing. And I will hide the window for the time being. Actually, change the, there we go. So what I'm going to do now is see if I can pop this off without having to take a bunch of stuff off. Let me. Do you let me? There we go. One silicone sock coming off. Ah, yeah. So I'm going to take this apart, and to do so, what am I going to do? What am I going to do? Try and find the wrenches that came with the hot end. I have somewhere. Wrench A and wrench B. So what's good? So we've got our input shaping done, and what we're trying to do right now is we use the camera over here, and we'll go through this procedure again, to line up our two nozzle tips. And then based on the two nozzle tips, we went and there's a Z end stop button right here that we use to check the Z height, and the Z heights are off. So what I'm going to do now is try and, well, the Z heights are off and it's larger than it would like for compensation. Oh, all right, well, and what I'm seeing and what I'm feeling here, why are you, oh, is there's a little bit of a gap between, there was a little bit of a gap between this extension piece, and I need to see if I can get that cranked on there a little bit, because what happened is the this tool head is a little bit lower than this tool head, and it's a little bit too much and it's complaining about the that distance. So what I'm going to do is try and work on getting the nozzle off of this now without breaking or shearing anything, because that would be bad. And then we'll try and get the whatchamacallit, the heat break installed and up there a little bit tighter. I do have a little tiny bit of filament left in here. Probably should have heated it up and poked it out first, because now I'd have to do that on the bench if I can't get it to easily pop out. But yeah, we're working on getting our tool heads aligned between the IDEX tool heads. And then what we'll do is I'll probably continue to work on this even after the stream, just because I'm not going to be streaming Saturday, because once again, I'm going to be helping Echovate. All right, so what I'm going to do is I'm going to stick this in here. I'm going to do kind of what I should have done first and heat this up. Try and push any filament through. And then I'll try and heat tighten this with and get any gap out. So heat up that extruder. And now mind you, Free Heathen, if you're looking, let me switch over to full display. So this is what we're dealing with right here. It says our Z offset, or the offset between our two nozzles, is 0.090938 millimeters. And it says that's too high of a gap. They want us to have a 0.07 or lower difference in the heights between these two tool heads. So, yeah, interesting, huh? That's the tolerances we're kind of trying to deal with here. So I'm going to heat this up to 270. And that will heat things up. It'll allow me to use my tool and push the garbage through. Well, I do have a clip. So one of the other things on this machine, Free Heathen, is we installed the Orbiter 2.5s with their toolhead sensors. So now if, like, this toolhead's completely off, well, not completely off, but it's cold. If I wanted to unload filament, I could click this button right here on the top. A little bit hard to see, but there's a little button right here. You click it, it'll run a macro that will heat that tool head up, purge a little bit, pull it up to make a good, nice tip, and then eject it out of the tool head. You have some flat bar to set it against to plumb them up. The problem is, you know, you've got the build plate, and the build plate itself is not I mean, it's within a tolerance spec, but it's not in and of itself 100% flat either. Oh, shit. Oh, I'm like, what the hell did it just do? It's loading filament. I shoved something in it and it was doing its filament load macro. That's the other thing that it does. That just scared the bejesus out of me. Oh, goodness. Um, okay. Let me untension it so that I don't have any tension that I'm trying to fight. There we go. All the nasty filament is now cleaned out. Well, just about. No blob there, and when I go to do this again, it's going to try and do the same thing to me. So we got the filament out, and what I need to do now is, now that we're heated up, I'm going to tighten that lower piece. And I can use their wrench, but I'm going to use my Knipex. I'm going to try not to snap this in the process, but yep, that's as tight as I'm going to get that. And we're hot, which means as soon as I go to put this in, then it's going to get hot as well. So let me drop the temp. And so this is what it says to do is, ads. So I, even if I put some flat bar stock up there, I'm not going to be able to tell if it's level to this rail from underneath. And I can't go off the bed surface itself because it's a triple lead screw bed. It's a kinematic bed. So it can kind of float around a bit. So bar stock sounds fun, but we're down at 150 something. I didn't realize how much gunk was on the front of this, or on this nozzle. So these are both 0.6 millimeter nozzles. Hardened steel nozzles. And I do have a torque wrench. The problem is my torque wrench is a 1.4 and theta suggests 2 point something. So we're going to torque this with the highly accurate elbow. And then I'm going to take it back up to 270. I'm going to plunge through it as well because there was a little bit of filament left in that tip. So I'll get it up to 270, which means whatever in there will be able to get pushed through because it should be ABS. And I will push that through, hopefully before it scares me and makes it dive to the left. Okay. That way there shouldn't be any chance of filament between that nozzle and the heat break. I'll move it back over to the right and I'll try and give it a little nudge again now that it's hot. And come back over here. So this will be a bigger camera. One of the best tools that I got was this plunger rod. It is a 1.75 millimeter with a chamfered tip on it, so it actually goes down into the beginnings of the actual nozzle tip itself. So you get almost all of the filament out of a nozzle with these. And it works really great for clearing clogs because that's what it is. It's the I'm not even going to attempt to pronounce whatever name on there, but it's basically a anti-clog tool, an unclogger or something like that. Okay, so we're back up to temp. I can smell that. I'm going to move this to the right some and grab my pliers again and give it a little bit of workiness at the 270 temp because metals will move when they're a little bit heated up. Be careful, you don't want to break the you don't want to break your Fadus by any means. And we're going to let that cool down. While that cools down, I'm not going to mess with the other one just yet. Actually, I probably should because I didn't heat tighten the heat break on that one. So let's see, let's click on left of that. So I just changed the tool head between tool head 0 and tool head 1. And before I heat this up, I need to try and get the sock off of it. There we go. I probably should have brushed that one off some. Remind me to do that before we're done here. 270. Hey, Kenneth D, how's it going? So Free Heathen, I'm definitely going to post pictures as I work on that sewing machine. I've actually thought about whether or not, if people are interested, and I'll throw it out there on my Discord, if people are interested, I'll stream that rebuild. We'll take it off of the we'll go ahead and take it out of the cabinet, and I will bring it up here, and we'll use the bench and we'll tear it apart, do whatever we can to clean it up, make sure everything's nice and good on it, and we'll get it back together. Okay, so this is now up to 270. I'm going to get up here on the heat break itself, give that a little bit of torque. And then we torqued this to the 1.4 Newton meters. Now we're going to get it that extra little ugga-dugga. So now both of these should be warmed up and good. And the good news is I cannot tell looking at the heat socks which one is a year plus old and which one's brand new out of the package. So heat sock wise, you know, they're looking pretty much the same. Be careful slipping that on and go from the, just push up on the edges. Don't be like I did the first time and go like this, because then you're going to put your hand on a 270C nozzle and it's going to tickle a bit. We'll change our extruders. I'm going to crank this one back up to 270 real fast and just try and clean it off with a brush. Just a brass bristle brush. Don't go front to back on this because you've got a beacon back there which is sensitive to metal and of course is a circuit board. So kind of go side to side when you're doing this to try and clean off some of that excess debris that's on it. It should make it prettier when we look at the camera to do the nozzle alignment here in a second. A touch warm, some would say. Exactly, heathen. Exactly. Ay, ay, ay. Junk off the bed there. I'll cool this down. And we'll want to wait for them to get back down to room temp. Probably go faster without an insulating plug on them, but we want to get these back down to room temp before we do the calibration procedure again, because it will it'll impact it, right? In fact, there is a procedure that we will do a little bit later after this that will deal with thermal compensation. So heathen. What do you think of these types of parts? So this is part of the RatPack air filtration. This groove right in here takes an O-ring to seal up the fan face as it's pulling air through the filter and then exiting out. This is, I mean, this is beautiful. See if we can't get it to focus in on, maybe not. I want it to focus in on the layer lines here. This is 3DO ASA glass-filled RatRig green. And it printed beautifully. we'll be adding this. This is the air filtration. So this is charcoal, activated charcoal and HEPA filter air filtration. You have to make some dinner? Okay. Well, we're gonna let this cool down for another couple of seconds here, and then we will get this thing moving again. Oh, and by the way, remember when I said I needed to get the filament out of there? That's the filament that was still in the heat break and the nozzle that I pushed. So yeah, that little plastic plunger, it does its job. It gets the junk out. Okay. Where are we at on temps? 60 and 40? Enough. I say that's good enough. So we're going to start that process again, which was home and then Z-tilt adjust. So we'll home all. And by the way, I did put grease on this, so it's lubricating up and as we raise and lower the bed. It is working that grease in that we put in the other day. Because remember, we went into performance mode and then it started making a bunch of screeching noise. It did not like performance mode on ungreased. I think those are palm nuts. I'll have to look again. I think they're palm nuts. Okay, so we're going to do a Z-tilt adjust. And once again, it's looking for a 0.02 millimeter difference between the 3 points. And our tolerance is not 0.01, not 52. So, I mean, we're getting really killer tolerances out of this. Okay, so we just did that. We're going to come back into VAOC. This is the part Heathen would love to see. I'm going to say start calibration. This is where we're going to go back and start looking into the light. And we're literally just going to drag that nozzle and make that center hole line up. And you see how much nicer that is? Once again, this is a 0.6 hardened steel nozzle. All I did was brush it off some. So you can see how it cleaned up around the face of the nozzle, and then you still have some plastic crud on the side there, but the nozzle's really clean. Now we'll switch over to T1. It'll take that snapshot. It'll move over the known deviation amount. And here is the same nozzle, just perfectly clean, never had plastic run through it. But interestingly enough, you can see the see down in the bore that there is still some milling junk from when it was drilled. Right? So pretty cool every once in a while when you get somebody that has a macro lens that can take photos like this. Pretty neat. So we'll go back to toolhead 1. It'll take that snapshot, move over to toolhead 1, or I guess toolhead 0. We're a little bit off, so we'll align that a little bit better there. You can still see some leftover junk in that nozzle. Just making very minor adjustments. And now it feels like I'm just getting nitpicky, as zoomed in as we are. Good there. I can live with that. Now we're going to run the Z calibrate the offsets. Now let's see if we got it better, if we made it worse. Okay, so what do? We calibrate Z offset, or calibrate the offsets for T0, T1, hit the calibrate Z offset, click the square in the top left corner to end VAOC. Back to mainsail. And we'll get a set of numbers down here. So we got some change. We went from 0.09 down to 0.07. So we got some good change there. We're still a little high, right? It wants us to be at 0.07 or lower. And I can't do the washer or spacer thing that they're talking about. The small plate that holds the electrical crimps together. No idea what it's talking about by that. But anyhow, I cannot change toolhead 0 because the what am I thinking of? We had that one strip screw. So I cannot add a spacer to toolhead 0. I think we're just going to live with it. I'm on a 0.06 nozzle anyhow. So I'm probably going to be doing a 0.3 first layer height to start with. So I'm going to live with that. Hue correction. This is where we would, I don't know, print something. Yeah, we'd have to do the slicer over here, and then we can look at the skew correction. And if we change anything for skew, then we'll have to go in and redo the VAOC calibration again. Okay, that's great. Slicer. So somebody said that Orca Slicer nightly builds supports. How do you get to nightly? Ooh, 2.3.0 beta. Thin style, 2D status, fusion rate smoothing, exposed interface shells option by receiver. I'm just checking to see if there's anything in here that talks about V-Core or adding additional printer stuff. I don't see that. Orca Slicer nightly builds. I mean, why not, right? We're on a Windows machine. 230 nightly build. You can do the portable, because portable will let me not overwrite and run it separately. Let's do portable. And I assume that I just need to drag this somewhere and unzip it. Yep. Okay, so I will track this. We'll take a look at the 2.3.0 beta nightly build has the V-Core IDEX in it. If not, we'll go back to Prusa Slicer. This back on there. That I still need to run PTF YouTube for the other side. I plan on just doing a single color at the moment anyhow. That single color, we'll try some CookieCAD PLA. Because why not? Bring you guys something over here. Nope. I'll have to put you over here right where I'm standing in a minute when we go to start print. And the plan will be to print the words on stream. The plan would be to print that skew correction thing. First off, I need to see if we've got the ability to put Orca, or not Orca. Goodness gracious. Prepare, printer, click there. Good news is it picked up all of my printers. Let's see, let's show you guys what I'm doing. That may be helpful. So I'm going to look for RatRig. We've got V-Core 3s, V-Minion, V-Cast, V-Core 4s, V-Core 4 hybrids. And look, V-Core 4 IDEX. Grab a 0.4 and a 0.6. Why not? So we have IDEX 300. We have IDEX copy mode and IDEX mirror mode. So we need all three of those eventually to play around with. So we're going to do RatRig or not hybrid. RatRig V-Core for IDEX 300 06 nozzle. Parthenax. I hope I spelled that right. P-A-A-R-T-H. Oh, you are Parthenax. Okay. We got a name to it. Test connection. Working. Good to know. So now we have the RatRig V-Core 4 IDEX 300 in normal mode, which should be just one tool 0 basically. We're going to PLA. We don't have anything. Sure. Generic PLA, whatever. Open, view calibration, layer height. Because we're on a 0.6 nozzle, we're going to go to a 0.3 layer height. And for the first layer, or no, we want 0.2 standard, 0.3 first layer, according to what it was wanting. Yeah, sure, whatever plain default settings for RatRig V-Core 4 IDEX 06. So we'll just grab that one. Boom, layer height 0.3, first layer height 0.2. Nope, we're going to go 0.3 and 0.3. Why not? Okay. Place, 17 layers. We need to install some filament, so let's get some filament ready to go. Okay. Filament. Flip this slightly. A little bit of a pointy angle. Ooh. Slides off so I can get to it from over here, make it easier. what I'll do probably tomorrow night off stream is I will work on, all right, filament was detected. It's going to be heating up now. There's the tool head kicking on. And once it gets up to temp, it's going to, actually it should have pulled it in a little bit already. Yep. So one thing that I like to do is put a little mark on my orbiter front gears so I can see if it's turning or one way or the other. Just a visual flag. But just gonna load this here. I'm gonna work on the wiring because this wiring is a little bit too long. So I need to shorten that up just a slight bit and get the metal back into it. Awesome. Okay, so let's change view. I will bring you guys and gals in closer. You just go bench side and we'll get rid of the thing for now. Orca print. View calibration 0.3 PLA G code upload and print. Upload complete. And it has file and it is starting to do its thing. Standby mode. Loading filament into nozzle. Please wait. Okay, you've got filament to the nozzle. It's not resetting from that. There it is. Just hadn't scrolled down or I had scrolled up. Post-processing error. Slicer version not supported. You can allow unsupported slicers by adding the following to printer config. RatOS allow unsupported. Okay, so we're going to basically it says it's an unsupported slicer version based on the slicers being passed in the G-code config or the G-code file. So I'm just going to come down here to the bottom of our print config and add that line that says, you know, use unsupported version, save and restart. And goodness gracious, that thing is loud. I may have to figure out how to get that changed. And I'm going to start that SKU calibration job. So it throws a warning of an unsupported slicer version. Only version 2.11 and 2.20 of Orca are supported. 230 not supported yet, may result in print offsets and incorrect stuff. Okay. So I just have to be on the lookout. Now, we have not, um, so we have not done any like first layer calibration or anything yet either. So the very first test we're going to do is this outlined skew correction thing, which I really ought to check, see if it was saying print it in a specific manner. As in, basically, is it telling me, or should I slice it in a specific way? Make sure the A corner is pointing in the right location. Oh no, is it? That's good. The A corner is in the right direction. That's good. Um, it also said it wanted us to yep, might have to run this a second time just because the I didn't check to see if there was any skew correction already active in the system. Going through and scanning. Waiting for the temperature to come up. And start to print. Right, it does a blob. So it normally did the blob over on the right. I'm assuming it's doing it on the left because this is the left tool head. Oh, like butter. Like butter. First test print on the newly minted IDEX. So this is Parthenax. It has been printing as a hybrid V-Core 4 300 size, and we have now converted it to the RatRig 300 size V-Core 4 IDEX system. And this is the skew correction model that we're printing. And so far, the first layer is going down beautifully with no change needed in layer height. This is using CookieCAD PLA filament to do the skew correction. We've got the 0.6 nozzle in and printing at 0.3 layer height. Ooh, I'm glad I stopped that. This is what the standard cooling fan sounds like for the RatRig. That is a 12-volt 4028 fan that is blowing right now as a part cooling fan. All right, so I was just taking a couple of short little videos that I can post a little bit later just to show the, hey, we now have an IDEX and we're throwing some plastic down. And I took a video on my phone with the way the fans are kicking on, and I'm going to see if you can even hear me talking, because that fan is loud. God, that fan is loud. But we are laying down plastic, and it's a little bit after 10 o'clock. I'm going to let this print, and because it's loud, I want to let this print, and I'm going to walk away, give my ears a little bit of a break, and I will work on tidying up the right-hand wire loom for the tool head. Like I said, pull the wires through a little bit, shorten the sleeving some, and get the spring steel wire in it. And then I will run the PTFE tube for that side, get the side panels slapped on. I've got to manage some of that noise, and we'll see if I stream again before Tuesday. But like I said, there will be no stream on Saturday, as I will be helping Echovate 3D move into their new digs. So with that, I'm going to take a good gander and see who we can potentially raid into. I know Janos should be up and running today, and we should be having some marble races. Fanagan's doing a little in real life. Politics building a printer. Zombies on. Is Big Jano not streaming today? I do not see Jano streaming today. So in that case, we're going to get ready to go over to Zombie Hedgehog. Zombie is a new Twitch partner, and he is putting together a snap maker. This is that 400 size build plate printer that he was talking about. But for those of you that are still here with me, please head on over and raid with me over to Zombie. You've been lurking all night? Well, awesome, Liz. Thank you. I will jump over here. Say thank you, Liz. Remember, Bang merch. Go to the link out on my Twitch page. We've got new merch for the channel. And yeah, I need to let this thing print. It is killing my ears. But thank you, everybody, for being here. The printer is up and moving again. It's pushing plastic. And we're going to take a look at this print. I will post some pictures a little bit later and see how we're doing. But thank you, everybody, for being here. You have a great evening. Have a great weekend. And I will see you guys next Tuesday, if not beforehand. Thank you, everybody, and have a good night. Bye now. And for those of you that are watching this later on YouTube, please like and subscribe down below. Make sure you click that bell to be notified of new videos as they become available. And YouTube's going to be suggesting a video over here based on their algorithm. Thank you all for sticking around, and have a great day. Bye now.